Welcome viewers to my YouTube channel. I'm so delighted that you are watching. I'm your host, Teacher Jonathan Musa. Today I want to take you through these types of graphs. These are graphs where you are given some information and then you are supposed to represent this information in form of a graph. Then you are given four choices to choose the one that correctly represents the information. So simplified mathematics is going to take you through how to do this. I will also take you through these types of graphs where you are given some incomplete graphs like the one above here. Then you are supposed to complete that graph following the instructions that will be given. You can also see down here we have another graph where you are told to complete that graph after you're given some information for you to complete. So I'm going to take you through how to simply go through those graphs. Welcome and enjoy. Now, before we attempt the first question, I want us to interpret how to work out speed in a travel graph, because it's very important you know how to interpret speed in a travel graph before you go through these questions. Like, for example, here I've written a speed of 10 kilometers per hour, speed of 8 kilometers per hour, and so on. So I want us to draw a speed of 10 kilometers per hour in this graph drawn here. So a speed of 10 kilometers per hour means for every hour the car or the person was covering a distance of 10 kilometers. So how do we represent that? We come and look at the graph. The first 1 hour from 7 to 8, that is 1 hour, I should cover a distance of 10 kilometers. So I will put an highlighter here to show where that line is going to begin. So I use my highlighter and I put a highlighter there showing that within an hour I covered a distance of 10 kilometers. And if I'm moving at this constant speed, the next hour from 8 to 9, that is 1 hour, I should cover another 10 kilometers, which will take me to 20. Then the third hour from 9 to 10, another hour, it should take me, I should cover another 10 kilometers, which should take me to 30 kilometers. Then the fourth hour, I should be at 40 kilometers because I'm moving at a constant speed of 10 kilometers per hour. Every hour I'm covering 10 kilometers. The first hour I've covered 10, the second hour another 10, which takes me to 20, the third hour another 10, which takes me to 30, and the fourth hour to 40. So I'll put a line here where my highlighter is. So I put a line from 0 mark to represent a speed of 10 kilometers per hour, like that. So if you start here from 7 to 8, which is 1 hour, he had covered a distance of 10 kilometers. The second hour up to 9, that is from 7 to 8, 8 to 9, it should have covered another 10 kilometers, which is taking me to 20. You can see the line is touching all that properly. So take note, if you are moving at speed of 10 kilometers per hour, what about within half an hour? If you have covered 1 hour, you are covering 10 kilometers, then within half an hour you should also cover a half of that distance, which is 5 kilometers. So if you're moving at a speed of 10 kilometers per hour at after 30 minutes, which is half an hour, you can see here it shows you have covered 5 kilometers. Just take note of that. We shall apply that in the next questions. A cyclist left home for town a distance of 30 kilometers at 7 a.m. After traveling for 30 minutes at a speed of 10 kilometers per hour, the bicycle got a puncture which took 15 minutes to repair. The cyclist then resumed the journey and reached the town at 9 a.m. Which of the following graphs below correctly represents the cyclist's journey? So we are going to go step by step looking at this information and then analyzing the graphs given here. Then we eliminate until we are left with one graph which is representing this information properly. So starting with the first information, the departure time was 7 a.m. All of them are showing that. They were traveling a distance of 30 kilometers. That is well represented in all the graphs, and the scale is also well represented. Then we are told that he got a puncture after 30 minutes. That is one thing to look at to eliminate some of the graphs. So we should see a smooth straight line that goes up to 30 minutes and then there is a rest. Starting with the first graph, the rest is coming after 30 minutes. From 7 to 7:30, there is a rest here. There is a rest beginning at 7:30, which is okay. The second graph, the same, there is a rest. The third graph, if you at 7:30, after 30 minutes, there is no rest. The line continues up to 8. This means this traveler traveled up to 8. After 1 hour, that's when the rest began. So this is a wrong graph because the information given is the puncher, he got the puncher after 30 minutes. That's when we should see the rest. So this is wrong. The third graph is also representing that information properly. So we have eliminated graph C. Then we move to, he was traveling at a speed of 10 kilometers per hour, meaning after 1 hour, he's supposed to cover 10 kilometers. After every hour, he's supposed to cover 10 kilometers. Does the first graph show that? The first graph shows that after 10 kilometers, after half an hour, he has covered 10 kilometers. That is wrong because we are told he was covering 10 kilometers after an hour, and this is after half an hour. That's when he has covered 10 kilometers. So this is a higher speed because he's supposed to cover the 10 kilometers after an hour. And when you look here, 10 kilometers have been covered within half an hour. These are the 10 kilometers. The line is here showing that he has covered that within half an hour. This is what attracted most candidates when this question was set in KCPE, but it was the very wrong answer. So A has now been eliminated. We move to B. He has covered, when he got the puncher, he had covered 5 kilometers within half an hour. That is correct because 10 kilometers per hour means within an hour he has covered 10 kilometers. So if you take half an hour, he will cover half of that distance, which is 5 kilometers. So for an hour is when he's supposed to cover 10 kilometers. So for half an hour, which is the 30 minutes, he has covered 5 kilometers. So that is very correct. When we move to the third one, within an hour from 7 to 8, you can see that's when he has covered 5 kilometers. That is a speed of 5 kilometers per hour. Although we had eliminated this one, we should not even look at it again. Then the fourth graph, the first 30 minutes, you can see he has covered 5 kilometers. So we are left with B and D because these two are correct. The last graph, you can see it shows the 30 minutes. After 30 minutes, he has covered 5. And if he has covered 5, after an hour, he'll have covered 10 kilometers. So which is the one represented well is graph B and D for 10 kilometers per hour. Let's move to the 15 minutes, which is the time it took to repair the puncher. So in B and D, we should see a rest of 15 minutes. Look at B. B is a rest of 30 minutes from 7:30 to 8. That's wrong. So we are left with D, which is showing a rest of 15 minutes from 7:30 to 7:45. So we have eliminated all the graphs and left with graph D. Question 2. If you had not understood question 1, I believe that you'll be able to understand better as we do question 2. A cyclist rode for 2 hours at an average speed of 12 kilometers per hour. He rested for 30 minutes and continued for an hour at an average speed of 8 kilometers per hour. Which of the following graphs below correctly represents the cyclist's journey? Looking at these graphs, I can eliminate graph D without wasting time because there was a rest of 30 minutes. Graph D has no rest. So we have easier time to look at the 3 remaining graphs because you can see in graph D there is no rest. It's only a change of speed. He moved at this speed, changed the speed from 12 kilometers per hour to 8 kilometers without a rest, and we are told there's somewhere he rested. But these 3 other graphs, you can see there's a rest. So we are now left with 3 graphs, A, B, and C. So the cyclist rode for 2 hours at a speed of 12 kilometers per hour. We expect the first hour, the cyclist to cover 12 kilometers. So we come to the first graph. The first hour is from 0 to 1. When we move up, it should take us to 12 kilometers. And this one takes us to it takes us to 8 kilometers. So the first hour he covered 8 kilometers. This was a speed of 8 kilometers per hour. So this is wrong. Then we move to graph B. The first hour from 0 to 1, we move up and it takes us to 5 kilometers. So the first hour he covered only 5 kilometers. This was a speed of 5 kilometers per hour, which is wrong. Then we come to the third graph, C. After now it's at 1, it moves from this point past 10 and then comes to touch the line at 12 kilometers. So we have found the answer so easily before even finishing the information, because a speed of 12 kilometers per hour means the first hour he is supposed to cover 12 kilometers. Then when we move the first hour, we move up until we get to 12 kilometers, because the vertical scale, one small square represents a kilometer. So we get this is 12 kilometers per hour. We can also check again. If the first 1 hour he has covered 12, the second hour it should cover 24. Let's try also to confirm. Then we move and we get up to 24. Then there is a rest of 30 minutes. You can see the rest comes between 2 and 3. That is the rest there. And then he continues at a speed of 8 kilometers per hour. So even without checking this, we are certain that the graph which was correctly represented was C, because we have eliminated all the other graphs. D, because there was no rest. A, because the speed was showing that after an hour he had covered 8 kilometers. This one was showing that after an hour he had covered 5 kilometers. And the correct one is this one, showing after an hour he had covered 12 kilometers. And after 2 hours he has covered 24, you double 12, and the rest is showing 30 minutes as indicated. We move to the third graph shortly after this. A bus left Nairobi for Nakuru, a distance of 150 kilometers at 6 a.m. After traveling for 1.5 hours at an average speed of 60 kilometers per hour, it got a puncture. It took 30 minutes to change the wheel. The bus then traveled at an average speed of 75 kilometers per hour for the rest of the journey. On the same day, a car left Nakuru for Nairobi at 6:30 a.m. and took 2 hours to reach Nairobi. Which of the following graphs below represents the bus and the car journeys? So in this question, we are going to eliminate the graphs one by one until we are left with one graph which correctly represents that information. So the first graph to eliminate, even before any calculation, would be graph A, because the information tells us the bus was moving from Nairobi to Nakuru. The car was moving from Nakuru to Nairobi. So they were moving in opposite directions. And that is only shown in graph B, C, and D, where the bus and the car are moving in the opposite direction. But in graph A, both of them are starting at Nairobi. The bus starts at Nairobi at 6, goes all the way to Nakuru. The car starts at Nairobi, moves from 6:30 to the top, which is wrong. The car was supposed to be traveling in the opposite direction. The line for the car is supposed to be in the opposite direction like in the other graphs. So we have so far eliminated graph A. Then we are told that the bus left Nairobi for Nakuru at 6 a.m. We should check whether all of them are starting at 6 a.m. So for the first graph, although we have eliminated it, we now move to the second graph, which is wrong. The bus here is starting at 6:30, and the information tells us that the bus started at 6 a.m. So easy to eliminate. So we have eliminated A and B. The rest, they are showing the bus starting at 6, the bus starting at 6 a.m. Then we move to the other information where we are told they were traveling at a speed of 60 kilometers per hour. To determine the speed, we need to know that after every hour they were covering 60 kilometers. So this graph, the two remaining graphs, we need to check that. So from 6 to 7, that's where we have 1 hour. We should move and it should show us that we have covered 60 kilometers. So when we move up, it comes and joins the line at this point. Then we determine the scale on the vertical axis. To know the scale on the vertical axis, we need to know how many squares there are from 0 to 50. And there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these 10 squares are representing 50 kilometers. So to know what a small tiny square represents, we divide the 50 by the 10 squares which are inside. So we get 50 by 10 is 5. So every small square represents 5 kilometers. So if I count from the bottom, from 0, I'll count 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. So you can see it matches with the scale. So note that on the vertical axis, a small square represents 5 kilometers. So back to determining the speed of 60 kilometers per hour. So the first hour here, we should see that he has covered 60 kilometers. So let's see, from 6 to 7, that's 1 hour. We move up until we touch the line, and we touch the line at this point, 2 boxes above 50, and we have just said 1 is 5, so 55, 60. So within the first hour, he has covered 60 kilometers as the information says. When we move to the other one, the same thing. After 1 hour, from 6 to 7, we move up, it touches the line at 60. So that's all correct. And then we are told he traveled for 1.5 hours. So you should move from 6 to 7:30. Then that is the time he got a puncture. And that is also represented well here. That is also represented well from 6 to 7:30. That's when the rest started. The rest was for 30 minutes. This is a rest of 30 minutes from 7:30 to 8, from 7:30 to 8. So far, all that information is correct in these 2 graphs. Then we come to, after repairing the puncture, he moved at a speed of 75 kilometers per hour for the rest of the journey. So after the rest, up to the end, this speed should be 75 kilometers per hour. This speed should be 75 kilometers per hour. So the next page, I will show you how to determine the remaining part of the journey after the repairing the puncture, to prove which one shows 75 kilometers per hour. So we are left with 2 graphs, and we want to determine which of the 2 represents the last part of the information correctly. We have already done everything, but we're in the last part where we are told the bus then traveled at an average speed of 75 kilometers per hour for the rest of the journey. This is after the rest. So if you look at after the rest, we want to know whether this is 75 kilometers per hour. I will show you how to do this. We also want to see, after the rest, is this a speed of 75 kilometers per hour? And before we do that, I want us to understand the scale on the horizontal axis. So on the horizontal axis, we have time, and we have from 6 to 7, those are 10 squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And these 10 squares are representing an hour, which is 60 minutes. So when you divide 60 by 10, the 10 squares which are in this 1 hour, you get each small square is 6 minutes. So if I am to count from one square to the other, I will count 6, 12, 24, 30, 36, 42, 48, 54, then 60. So each small square represents 6 minutes. So in this case, for us to know which of the 2 gives us a speed of 75 kilometers per hour, we know speed is given by distance divided by time. I've drawn a triangle here to show you how to calculate speed in this curve. So this line here will give us the distance. This line here will give us the time. This line here will give us the distance. This line here will give us the time for this slope here. And we shall be able to know what speed is this. So we get the distance from here up to here. And this is 150 and this is 90. Because we saw that each is 5 kilometers, each small square. So we subtract 150 minus 90, which is 60 kilometers. So the distance is 60 kilometers. Then we come to the time. The time here is, we count the small squares. There are 1, 2, 3, 4, 5, 6, 7, 8. 8 small squares, and we have just seen that each small square on the time axis, on the horizontal axis, represents 6 minutes. So we multiply 8 by 6, which is 48 minutes. So we want to get the speed, and the distance we have seen, it is 60 kilometers. This is the distance. The vertical line here shows the distance of the curve. This line shows the time. So before we divide, we change 48 to become an hour. So what fraction of an hour is 48 minutes? We divide 48 by 60. When you simplify that, it becomes 4/5 of an hour. 4/5 of an hour. 4/5 of an hour. So we are now dividing 60 divided by 4/5. And this means 60 times, you reciprocate 5/4, which gives us actually the 75 we are looking for. 15 times 5, 75 kilometers per hour. So I repeat again, to get this remaining speed for the remaining part of the journey, we draw a line here to represent the distance and a line here to represent the time. This triangle helps you to identify the distance he has covered and the time he has taken in this curve, in this line here, the last part of the journey. And the distance we have got, it's from 150 to 90, which is 60 kilometers. The time we have got from here, there are 8 squares, and each square is 6 minutes. So these are 48 minutes. So we are dividing 60 kilometers and dividing distance, which is 60, and 48 minutes. We have to change the minutes to become an hour. So 48 divided by 60, we get it's 4/5 of an hour. So distance divided by time is the one which gives us speed. So 60 divided by 4/5 means 60 times 5/4, which become 15 times 5, which is 75 kilometers per hour. So this has proved to be correct because we are told the last part of the journey traveled at that speed. Then when you come to the other one, just to confirm, we look at the distance here. It's also 90, from 150 to 90. When you subtract, you get a distance of 60. Then the time, it's from 8 all the way to exactly 9. So the time is 1 hour. So when you divide a distance of 60 kilometers by a time of 1 hour, it tells you that this speed was 60 kilometers per hour. So that is wrong. So we don't even need to go for all the other information about the car, because we have already eliminated A, which was showing that they are traveling in the same direction. We have eliminated B, which was showing that the bus started at 6:30 instead of 6. We have eliminated C, which is showing that the last part of the journey, the speed was, we have not eliminated C, we have ticked C, but we have eliminated D, which is showing that the last part was traveling at 60 kilometers per hour, and we know that the last part he traveled at 75. So we are left with C. Ahmed left home for Nairobi at 7 a.m. After traveling for 1 hour and 30 minutes at the speed of 80 kilometers per hour. He rested for 30 minutes. He continued the journey at the speed of 50 kilometers per hour for 1 hour, and then at 60 kilometers per hour for 30 minutes. And then which of the graphs below correctly represents Ahmed's journey? So just like in the other graphs, we are going to look at the graphs, look at the scale before we even start any calculation. And when I'm looking at them, I've already eliminated graph B. Simply because any graph should be starting with, or the vertical scale should be starting with 0. This one starts with 50. You can't start a graph with 50 kilometers. Look at all the other graphs, we should begin with 0. The distance line should start with 0 mark. You should start from nothing, that is at the start of the journey before you have covered any distance. It should show that you are starting at 0 mark. But this one shows that you are starting at 50 kilometers, which is wrong. So B, whether the other things are right or not, graph B is already out. So we are now left with graph A, graph C, and graph D. So we are told that after traveling for 1 hour and 30 minutes at a speed of 80 kilometers per hour, let's determine this speed of 80 kilometers per hour to eliminate some other graphs. So the speed of 80 kilometers per hour means for every hour, it should cover a distance of 80 kilometers. So let's see the first hour for the first graph. And before we do that, we need to know the scale on the vertical axis. This is just like the other graph we have discussed. 50 kilometers are within 10 boxes, 10 small squares. So every small square is 5 kilometers. So if we move here from 7 to 8, that is 1 hour. We move up. At this hour, we should go up to 80, and this takes us only to 50 kilometers. So within the first hour, he only covered a distance of 50, and we are told that the speed was 80 kilometers within an hour. So this is wrong. We have eliminated A. We are left with now graph C and D. If you move from 7 to 8, this is an hour. Then you check within this first hour, what distance has he covered? This is 50, 55, 60, 65, 70, 75, 80. That is well represented there. That is 80 kilometers per hour. When we come to this hour here, we get after an hour, he has covered 55, 60, 65, 70, 75, 80, which is correct. And then there's something else which will eliminate one of the two graphs. We are told that he traveled for 1 hour and 30 minutes. The two of them agree with the speed of 80 kilometers per hour. But you are told that he traveled for 1 hour and 30 minutes and then rested for 30 minutes. So he traveled for 1.5 hours before the rest. So in this graph here, the rest is only coming after an hour. You can see the rest comes at 8, which is wrong. He rested after he had traveled 1 hour and 30 minutes. So the only graph which correctly represents that is graph D. This is 7 to 8, then again 8 to 8:30, and that's when the rest came after 1.5 hours. So far we have eliminated all the graphs except graph D. A, I repeat, we eliminated A because the speed was not showing 80 kilometers per hour. The first hour, he has covered only 50 kilometers. B was wrong because of scale. You can't start a graph with 50 kilometers. C was wrong because the first was showing speed was 80 kilometers per hour, but his rest came after an hour, and the rest was supposed to come after 1.5 hours. So the one which is representing that is graph D. So we don't even need to continue with the other information because we are only left with one graph. So do a lot of practice on those graphs. I think the 4 examples, anytime you just go back to them and listen and watch and look at them keenly, they will help you through those types of graphs. The next page, I will be showing you how to work out graphs which are incomplete. What should you do to complete them? So don't go away, just come back after 2 seconds. Now we come to the second part of graphs which are incomplete, where you are given information, and from this information you are supposed to complete the graph according to the information given. Like this question saying the graph below shows part of Menya's 90-kilometer journey. After covering 40 kilometers, he rested for half an hour. He then continued at a constant speed of 20 kilometers per hour. At what time did he complete the journey? So we are told that it was a 90-kilometer journey, so the journey should end at 90. And after covering 40 kilometers, so from 40 kilometers where he has reached here, we should have a rest of half an hour. That would be quite easy to put a rest, which is just an horizontal line from 8 to 8:30 there. And then from there, we are supposed to show a constant speed of 20 kilometers per hour. How do we put the 20 kilometers per hour? In the next page, I will show you that. So having put now the rest of 30 minutes up to here, we now see how we can put the speed of 20 kilometers per hour in the next page. So welcome back. We continue analyzing this question where we are supposed to complete this graph. We were told after covering 40 kilometers, he rested for 30 minutes. So this this line here represents that rest. So I replace it with a black line. I replace it with a black line there to represent the rest. Then I want to show you how to represent the rest of the journey which he traveled at a speed of 20 kilometers per hour. So to represent 20 kilometers per hour, you'd use these two lines here. You'll move from this place where he has finished the rest, move up by 20 kilometers, that is from 40 to 50, 50 to 60, those are 20. The 20 kilometers are to be covered within an hour. So from this 20, you move from 8:30 to 9:30, which is 1 hour. So you put a dot or highlight at this point here. This is where your line is going to pass through. So I repeat again, as after the rest, he moved at a speed of 20 kilometers per hour. What does that mean? You move from this point up by 20 kilometers, that is 40 to 50, 50 to 60, those are 20 kilometers. Those 20 kilometers are being covered within an hour. So from here 8:30 to 9:30. So that line of 20 kilometers per hour should be touching this point here. And how did I get that? I will not get tired of repeating. A speed of 20 kilometers per hour from this point. I will draw a line to represent 20 kilometers from this point here where he has finished the rest, up to 40 to 50, 50 to 60. Those are 20 kilometers, and the 20 kilometers are covered within an hour. Then I put from 8:30 to 9:30 up to this point. So I put a point here. That is where I will join this point with this point here with a straight line going up to complete the journey. So I will take my line and place it there. After I finish the rest, it should be touching here where 20 kilometers and 1 hour are coming to touch one another. That is at this point. So this triangle here shows 20 kilometers covered within an hour. So this line I've put here, which should be drawn by you, represents now the rest of the journey, which was covered at a speed of 20 kilometers within an hour. 20 kilometers within an hour. So I now remove these lines which were just there to guide you. And then you look at what time did he complete the journey. The journey was to be completed at the journey was for 90 kilometers. So this is the end of the journey. So you move until you touch the line that you have created, and it touches it at 11 a.m. So the journey ended at 11 a.m. The graph beside shows part of the journeys made by Chebet and Care on the same road. Chebet traveled from town Y to town X at a constant speed. Care traveled from town X to town Y. After covering 20 kilometers, he rested for 30 minutes. He then continued at an average speed of 40 kilometers per hour. Complete the graphs of the journeys. At what time did they meet? So starting with Chebet, for Chebet it's very easy, because if you travel at a constant speed, it means the gradient of the slope given, this line given here from town Y, you'll move in the same direction all the way to the bottom, because the speed did not change. So it continued the same direction and the same way it was moving up to the end. So when you go to the next page, I will just draw a straight line to represent Chebet going up to the end. Then when you come to Care, Care traveled from town X, from the bottom here, to town Y. We are told after covering 20 kilometers, which these are already 20 kilometers, he will have a rest of 30 minutes, which I'll put a rest of 30 minutes, and then he continued at an average speed of 40 kilometers per hour. The next page I will show you, just like I've done in the other question, how to put a distance, a speed of 40 kilometers within an hour. So when we move to the next page, I will use lines to explain to you how to draw Care's journey. So I've used some lines just like in the other question to guide you, to show you how to complete the journey. So for the first person, that was Chebet, who was moving at a constant speed, I've just extended the line in the same direction up to the bottom, because the speed never changed. There was no rest, there was no increase, but the same direction and the same gradient. So that's how we continue the journey of a constant speed. Now for Care, after covering these 20 kilometers, he rested for 30 minutes. This line here represents the rest for 30 minutes, which I should replace it with the right line now. So I draw a rest of 30 minutes. Then from there, he continued with a constant speed of 40 kilometers per hour. So just like I did in the other question, I show a rest of 40 kilometers per hour. So from where he finished the rest, I move up by 40 kilometers. From 20 to 40, those are 20. Then from 40 to 60, that's another 20. Those are the 40 kilometers. And then 1 hour is from 8 here up to 9. So 40 kilometers and 1 hour. So I'm going to put a point at this juncture here. So at this point here, I'm going to put a dot here, then draw a line from this point where he completed the rest, and then join the line moving upward. So I replace with the line, the right line, which I'm supposed to draw from there to touch that point where 40 kilometers meets with 1 hour. And then I rub now these lines, which are just to help me, and before I rub them, I repeat to get the 40 kilometers per hour. I've just moved up by 40 kilometers and by 1 hour. Then I put a dot here, then I join a line from this point where the rest ended, and then I joined with a straight line. So I now remove these lines. So now I read the question, which says, at what time did they meet? So they met at this point here, and that was at 9 a.m. This is where Chebet met Care.